Question B. If gamma yy is equal to 0, that was given, then the cost function is homogeneous of degree alpha y in output. And so that's a simple application of Euler's theorem that you had in undergraduate calculus. And so that shouldn't have caused any problem. Most of you picked up on that right away. No trouble with that. The other hint that I gave you was, again, that as you move away from the origin, that in the isoquant picture, that as you double the distance of the isocost curve from the origin, you've doubled cost. And the question is, what happened to output as you doubled cost? And then, if you've doubled cost and output less than doubled in that figure, then average cost had to have risen. And so in order for average cost to have risen, then there had to be a function of alpha y. So the degree of homogeneity is given by alpha y, and if you want to have constant returns to scale, then alpha y had to be 1. Then you were supposed to derive the cost shares. That's no big deal, although I guess the way the question was posed was not exactly transparent. I'll have to rewrite the way the question is written. It's just the derivative with respect to the log of the prices by Shepard's lemma that gives you differentiating, log differentiating by Shepard's lemma gives you the factor share equations. Then there was a question about, said you were supposed to estimate the factor share equations by ordinary least squares. Ordinary least squares means forget about questions of serial correlation, heteroscedasticity, multicollinearity, all kinds of, if I wanted those things, I would ask for them. Okay? The homework was very much like a cookbook. How many of you cook? How many of you own a cookbook? So a bunch of you cook but don't own a cookbook. How many of you own cookbooks and follow them? And read them and use them? Well, the homework assignments, my homework assignments and my exams are in the nature of cookbooks. It requires a little bit more thought, but an interpretation than a cookbook, but if you follow the steps, you're not likely to get into trouble or wander too far from what I'm after. The ingredient list may have been problematic, or exactly how much of a particular ingredients you put in, but that's why you're here, to learn those things. So I didn't want to hear about heteroscedasticity and serial correlation and yada, 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 and so on and so forth. Very common mistake. I wanted some. Who would like to tell me about error propagation? Anybody? Want to tell me about error propagation? What's propagation? P-R-O-P-A-G-A-T-I-O-N.
Put forward.
We'll look it up in what do you call it? Dictionary.com.
Does that mean an error in an earlier step flows through to later steps?
Right. An error someplace is transmitted through to another place. So error propagation means that the error is fed on to subsequent steps, for example. So if you see a word, if I use a word in class or in a homework that you don't know, there's always dictionary.com, and the other great resource that I'm sure you already know about is Wikipedia. That's a great resource. I've never found any really egregious mistakes or misleading material on Wikipedia, and I've also never had any trouble with dictionary.com. Multiplication by natural reproduction would be propagation, or the process of spreading to a larger area or greater number, dissemination. So error propagation means that somebody makes a mistake, and then this mistake sort of takes on a life of its own as it gets spread out to other people. So a common mistake that I saw was that, for whatever reason, people interpreted y in the cost function as total revenue. Why would the cost of producing widgets depend on total revenue? It depends on output. So a common mistake was there were a whole bunch of people who used total revenue instead of output on the right-hand side of the share equations. So to come back to this. So you had to estimate the 4 share equations. The 4 share equations had on the left-hand side the cost share. From what I could see, pretty much everybody computed the cost shares correctly, and then on the right-hand side you had the logs of each and every price, and you also had the log of output, not the log of total revenue, but the log of output. It took me a while to figure out that that was what people had done, I tried experimenting with different specifications and all kinds of different things to figure out why, at that step, so many people deviated from what I had done. So then there was a question: do the symmetry and equality restrictions hold? And now you know, by looking at your own answers and the grading, you now know why I usually try to make things work like a cookbook. Because there's nobody who remember, oh no, that's not true. There were two people who remembered what we're in the business of doing. What are we in the business of doing?
Testing hypotheses.
Testing hypotheses. So if I ask a question like, do the symmetry and equality restrictions hold? You say, oh, the light bulb should come on, and you could say, I'm going to spend the rest of my life testing hypotheses. I bet that's what Dr. Buck wants me to do right now. Test some hypotheses, especially since one of the in-class things, the discussions that we had, was that homework assignment of Better Bread and Meat, in which we spent a lot of time explicitly talking about testing hypotheses. Right? So there were two people, the light bulb came on instantly, and they said, oh, there are these 5 equality restrictions that we were given in the statement of the problem set, and then there are 6 more symmetry restrictions, resulting from the fact that, for example, gamma 1,3 appears in 2 different first-order conditions. Gamma 2,3, gamma 1,2, gamma 1,3, gamma 1,4 all appear in 2 different first-order conditions. Gamma 2,3, gamma 2,4 appear in 2 first-order conditions, 2 of the share equations, and gamma 3,4, the last one, appears in 2 places. And so you got these 6 symmetry constraints for you that you need to test. You can pick whatever level of significance you wanted. The first 4 are linear combinations of the coefficients. We talked about how to do those. Remember we said that the generic representation of a t-test is t is equal to, in the numerator, alpha transpose, where alpha is a vector of your choice, beta hat minus r, where r is a scalar of your choice, and then in the denominator you had the square root of alpha transpose times the covariance matrix for the beta hats, first multiplied by alpha, and that had a 2 distribution. So don't forget, going forward, that most of your careers will be spent in one way or another testing hypotheses, whether you are working as financial engineers in private industry, if you're trying to convince somebody that there's a new financial instrument that they need to invest in, you're going to have to be able to convince them that this is going to work the way you say. You have to present them with a compelling test of hypothesis, that your construct is better than what's currently available. So in estimating the share equations, if you use total revenue in place of output, I think you lost a couple of points. It wasn't the end of the world. It just took me a while to figure out what you had done. So the test for the sum of the intercepts in the numerator, you have the sum of the intercepts, and they were supposed to add up to 1. The sum of the intercepts minus 1, and you get a test statistic that's minuscule, and so the sum of the intercepts is 1. In a statistical sense. The coefficients within an equation are supposed to add to 0. So from your software, you can harvest the coefficient covariance matrix. That's what I did here. I just cut and pasted it into MathCAD. I defined my own version of alpha, which I called RES, and it was the same across all the within equation restrictions.